Okay, so I've tried recording this like 5 times now, and I've been interrupted like every time. Um, Anyways, so some people were asking how I make my light cycle trails for my senior project thing that I did a few years ago. Like I said in that post, it has been a few years, so I'm not too savvy on exactly how it works. I'd have to relearn what I did. But anyways, I used the Niagara system. I made an empty particle or new particle, whatever it is. I changed the render mode to be a ribbon renderer, and you can take a look at this. I'm not too sure exactly what you need to know, but anyways, so I have all of this. So spawn count 1, lifetime 3, so 3 seconds. And then the color mode direct set, and the color is a variable or a parameter that you can set using other blueprints. So there's that. The ribbon width is how tall or wide, how tall in this instance your ribbon needs to be. And then ribbon rotation, I'm pretty sure that this rotates it on the z-axis, so it's facing upright instead of on the ground. So there's that. I'm not too sure what else you need like around here, but the material is this one right here. So because the texture stretches out, and I didn't want it to like tile, I did text coordinate 0 for the UVs. And then this texture is just like a gradient with like 2 light bars. So like one on the top, one on the bottom. Then you've got that going into a blend overlay. So that overlay is the RGB values of the particle. So you blend those together, and then the result you put into the emissive color. Then you take the RGB and the noise, you multiply it by some number depending on how noisy you want it to be, and you add those together and put that into opacity. So the white parts are not only the brightest, but they also have they're the most opaque, so that they actually emit the color. Because if they're transparent, they just won't emit the color. So then you can take that noise and the alpha of the particle color, lerp between whatever you need, and then that'll go to the refraction, multiply it by I guess 100, and then apply that to the normal as well, so that you get that texture. And so that would give you texture, and then this gives you the glass-like material to it. So, and of course you can just take a look at this and take what you need. And then when it comes to actually making the trail work, we've got 2 different things. So we've got the create and color the light trail, and then we've got detach the light trail. So you'll want to have a variable or a parameter for when the light cycle is trailing or making a trail. And so if it's false, then we can come down here. So if it's false and the current speed is more than 0.4, that's like a normalized velocity. So if it's more than 0.4, then it will, and the input from the player is true, then it'll spawn the new system. So the reason that there's a current speed thing is because when I was making it, it looked kind of weird having the trail start when you're at like 0 velocity, and so there is a certain velocity that needs to be met before it'll start the trail. So then when those parameters are met, then you have the spawn system attached. The system template is the cycle trail, the particle that was set up here. And then I have attached to component, the capsule component. That's the collision for the bike, I think you should be able to attach it to like the skeletal mesh or just the normal mesh. But I did the collision for whatever reason. And then because I did it with the collision, there wasn't like an attach point that I could use. I don't think. I'm not too sure on how the attach points work. But anyways, I decided to just use the location thing to change where the particle spawned from. So in my case, it was negative 206.5, so that it was at the back of the bike, and then I think this was used for positioning it upward. And then location type, keep relative offset, auto activate, prequel check, anything here. I don't know exactly what you'll need. And then we have a variable or a parameter that we'll set to this. So this variable will return this system, if that makes sense. And then with that being set, then we can do the change color function, and then it'll set trailing to true. So this is a custom function where all it does is set color parameter. Target is FX system component. And then the parameter name is light color. So the same name that you set up over here in the particle. So light color, and then over here it says parameter name, light color. And then this light color here is the one that is attached to the bike, so that the bike's lights on them and the trail have the same color parameter. Then after this has been made and the color has been changed, then it'll set trailing to true. So now if it's true and the current speed is less than that threshold we set up here, down here, or if the input from the player is false for the trailing, then it will detach from component. The target is the trail, the variable that you set up here. And then I don't know if you need to change anything here, but yep. And then it'll set trailing to false, so that it can set up this sort of thing again whenever the player inputs that again. So there's that. And then I'll just do a quick just like pan over the entire light cycle controller, so you can make one for yourself. So I'm not going to be able to explain all of these things. There's probably a bunch of variables or parameters right here that you'd need to set up. Like I said, it's been a few years. I'm not exactly sure what does what. I'd have to relearn all the code and familiarize myself with it. But yeah, if you wanted to use any of this code, I mean, just like put a comment in your code, just I guess crediting me. So there's that. This is the whole camera system. I'm not sure if you really need that, but there's that. Then right here we got simulate physics, blah blah blah. And then this is where the like sort of animation for it comes into play, because I didn't know how to do it like physically. So a lot of this is just like the animation for it done using programming, because I wasn't sure how to even program something like that. So yeah, there's the drift factor calculations. Like I said, I'm not too sure how all of this works. But yeah, if you'd like to make something like this, here's the code that I used to make it.